Okay. How's everybody doing today? Good? How are you guys? Good. I'm really good. Um, so this week on Wednesday, we're going to begin actually a unit project for the design process. The unit project for this unit is going to be like a long project. We're going to be working on it for 2 weeks. It's going to be a group project, and it's going to be a design activity. Today is an introduction, and again, we've already done 2 design activities already, so we're kind of building upon what we already have done in this unit. But to begin this activity, or this unit, we're going to go through this really quick activity. This ideally should be done by the end of this period. This is a very quick, like, 1-day activity. If it's not done by the end of this period, it is due by the end of today. It's due by the end of tomorrow for the South kids, but for you guys, it's due at the end of today. So there's this worksheet here. The engineering process helps engineers and other problem solvers come up with creative solutions. You are an engineer. Choose one engineering problem below and follow the steps to invent a solution. So one thing that I want you guys to note here is that you are an engineer. You're not a designer in this case, okay? Designers care more about the way that things look. Engineers tend to care more about the way that things function. If you take a look at Classroom and you look at this, we're going to be concentrating on how the system is going to work today. This is about function, not form. Which really means that I'm looking for like a drawing that clearly communicates your idea, but I'm not necessarily looking for a drawing that has like shading in it, or realistically, like any of the things we've really been like hammering in the sketching unit. This is more about using those skills to clearly communicate an idea quickly, but this is about how it's going to work, not what it looks like. Okay, so again, you're thinking like an engineer here, not like a designer. So there's only one constraint that I'm going to give each and every one of you for this activity, besides, I guess, the due date, which of course time is a constraint as well. But the one constraint that you have here is no electronics are allowed. None. Okay, so everything that you're going to be designing is going to be a mechanical fix of some sort.
Good afternoon. Will the following students please report to the health office? Samir Abazadeh, Ethan Hall.
So once again, no electronics are allowed in this activity. And once again, for you North kids, this is due at the end of today. For the South kids, it's due at the end of tomorrow. So what you're going to do, we're going to take a look at these 3 different activities. The first one, your new pet kitten is trapped in a 10-foot deep hole. Need a contraption to safely rescue your poor animal. So, once again, I really don't care about how the hole looks. I really don't care about the little cat. I care about the thing that you're going to send down into the hole, what that looks like, and more importantly, how is it going to function? How are you going to lure the cat into it? We don't want the cat to like jump out of it again, so you need to like contain your cat within that unit, and then safely like pull your cat out from that hole. It doesn't list any sort of information about how big the hole is, so you can assume that basically anything you stick down there will fit. You yourself are not allowed to go into the hole to remove the cat out. You got to think about safety of the animal, right? The next one, you're going on vacation for a month and you can't find anyone to water your plants while you're gone. You need a device that will give your plants the right amount of water, not too much, not too little. That one, in my opinion, is particularly difficult. And then lastly, you like to read before you go to sleep, but you don't have a bedside lamp. You need a way to turn off the light switch across the room without having to get out of bed. Okay, so again, these are 3 engineering design problems that I'm looking for a mechanical solution to. You can choose any one of the 3. If you decide after you've chosen one of them that honestly, like, man, I'm having a hard time with this and I'd rather change my choice, by all means, change your choice. By the end of today, you're going to be scanning 2 separate things to turn into me. The first thing you're going to be scanning is this first sheet. What problem did you choose? You're going to write it out, and then you're going to write out some brainstormed ideas on how to solve it. Then you're going to choose one of those ideas, and on the back of this page, you're going to draw a detailed picture of the solution you chose, label the drawing to explain what each part is made out of, how the parts fit together, and how it will work. Once again, how it will work is the most important thing here. Then lastly, where do you think you're going to run into problems with your solution? Where do you think the weak parts in your creation will be? This is like the evaluation aspect of the project. There is nothing wrong with recognizing the fact that you will have a weakness within your design. Basically, every design has some flaw in it. So you feel free, please, to write down where you think your weaknesses will be here. Zishan, please mute your mic. Thank you. So that's the activity for today. Again, this is a one-day activity. Choose a solution, brainstorm some ideas, draw a picture on the back or on if you don't have a printer, answer all these questions on a piece of paper, and then flip the piece of paper over, sketch your design, and then you're going to turn that stuff into me. Once again, we are focusing on how it works. That is the main thing that I'm grading here, how it works. Any questions from either groups? Okay. So let's begin with page 1, and then once you get to step 2, get to the back and start drawing it out.